Welcome back to Ox Tools. I'm Tom. Last week I did a video on shop updates, and in that video I showed my very sick 6x48 shop built belt sander. So for those that hadn't seen that video, go back and watch it. And anyway, it's a belt sander that I built many years ago, back in the I don't know, late 80s or early 90s, somewhere in that regime. I'm kind of dating myself there a little bit. Anyway, the motor bearings finally went out, so it was an opportunity to kind of go through the whole thing and do some repairs, some much needed repairs, I'll say. And anyway, that's what this video is about. So let's get cracking, because I am wanting to use that belt sander. I've missed it already. It's only been down for a couple of weeks. So let's get cracking and see what we can do.
All right, let's get this cable out of here first. Discombobulated. Thing's only been in here for 30 years, huh? Wow, it's even still has some flexibility. Amazing. All right, let's not try to be a hero there. Pull it off that way. Oh, that's good. My thing still works. Okay, I got some new cable here. This is okay. Yeah, that's pretty tasty. I think I'll strip it first before I put it through there. It just makes it a little easier. And don't ever forget to put that on first, right? All right, let me get my stripper. I don't know if you guys have seen this type of stripper before, but it's for this rubber cord cable, and has a little blade there, you can see, and you can adjust the depth of that blade, and I can tell you right now that it's out too far. That looks better. And I always, you know, unless I'm really short on cable, I always strip more than I need. The trick is to not cut quite all the way through. You don't want to nick the conductors underneath. Just close enough to where it separates. Okay, don't lose your stuff, Mr. Wizard. And then we'll slide that off, hopefully. Okay. And then we expose our conductors. Okay, and I'll trim all this business off. If I got my little nippers here. Cut this out nice and close. Get this stuff out of the way. So, okay, and then we go through the nut first, and then the bushing. I suppose I could have put it through first, but, and this slid it back and forth, but let's do it like this. And you want to make sure you got plenty inside, which, yep, that looks pretty good. Okay. So one thing that's almost free and is important is to make sure you got a good spot for your ground. I noticed that previously the paint was still on it, so I don't know if I did that or somebody else did that. I don't remember who wired this thing originally. I think it was one of the guys at work, but I don't remember precisely. Anyway, then we're going to crimp a lug on there. Let's see, insulated, uninsulated. And crimp the snot out of it. Okay, and then if you ever notice, electricians got these like like serious meat hook hand. Oop, shoot. Serious meat hook hands, right? Because they're always gripping and I wish I had my little magnetic driver right now, right this second. All right. This is pissing me off. We're starting to. All right, I think I got it. Because they're always, you know, gripping and twisting for all they're worth, right? To make good, tight connections, low resistance connections. You see them like this, her. Okay, that looks pretty good. All right, I'm gonna pop these wire nuts and get these others on here. So we got, I got the hot plate going here, which is like smoking hot. Oops, turn that down a bit. And what I'm doing here is I just want to heat, I'm going to do the little one first. I just want to warm up the inner race a little bit so that it slides onto the shaft easy. But we'll do the bozo check first. Make sure it doesn't just slide right on there, which I kind of don't expect it to. No. Yeah, they did not make this shaft very stepped. They didn't step the diameters very much. All right, so let's set that on there, and that's going to warm up just the inner race there. Actually, I'm going to turn it down to low because I'm scared. I don't want to overheat it. So we'll let that go for a sec, and then we're going to slip it on the in this position right here. Jeez, that seems awful tight, folks. There we go. Okay. We're good. So why do they do that? You know, all they had to do is take a couple thou off of that, and then you're at least at the start. It started nice and straight and everything. You know, they must have a fixture to help with that or something. All right, let's flip it around and we'll do the other side. Hey, this one's a lot better, right? It gets it started right on the spot where it needs to be started, and then I got the washer under there, right? Yep, okay. Okay, see, that was easier. That's how it's supposed to be. All right, I'm uptight on the washer. Cool. New bearings. All right, let's go for it here. Oh, that's nice. So that bearing is not a super tight fit in this rear cast housing. Now this one is a little snugger here, and it's got a preload spring here in the front to allow for thermal expansion of the shaft as this motor heats up, gets longer. So this wave spring accommodates for that. That's good design practice there. So now I will tell you this, getting this end bell off was a little bit of a hassle. This is a close fit here between the aluminum, this aluminum end bell and the steel of the motor. So I got to get this lined up properly here. And where's my persuader here? I got the tie rods here. And I'll push those all the way up. And that'll be my, well, the thought is at this point, what I'll probably do is just warm this up a little bit with a propane torch just to expand this a little, and then slide this on very carefully. Let's just do a little check fit there. It's pretty good, huh? Yeah, I mean, I can actually preheat that just right there. That'll be pretty easy. I'll get some nuts and an appropriate driver here, and then we'll just suck that on, and Bob's your uncle. Be right back. Okay, so I've shown these before. These are impact sockets made by Makita, hence the name. And Stan from Bar Z turned me on to these, and they're just really nice. And I bought a new set recently, and here's why. My previous gripe on these, other than that, you know, as a minor gripe actually, is the sizes were marked at the bottom, so you couldn't see them from the top. Now, a bunch of smart Alex said, "Oh, well, you know, you're experienced enough. You should be able to look at those and figure out what's what." Yeah, you're right. But now these come and they're laser engraved. Now, I lost one from my previous set, so I had the absolute perfect excuse to buy more tools, which is all of our goals, right? So these are 7/16, so we're just going to pop that. Anyway, these are really nice. They're like, I don't know, $15 at Home Depot. And this vinyl case is just nearly indestructible. And it's just a nice setup to include with your Makita Impact, right? Okay, so we're in. So since I got such a nice mechanical advantage, I found some nice thick washers here to spread that load out there. I think I'm gonna, come on, what's your problem? Of course, the last one that I said, oh, I'll film one of these. That's the one that doesn't cooperate. How do you like that? Oh, you little monkey. All right, let me get another one. Jeez. Right. So since I got such a good mechanical advantage here, I think I'm just gonna try it cold here. You know, since I can just pull it up a little at a time. Yeah, it seems to be going nicely here. Yeah. Save me some messing around. Pretty close now. Yeah, it's coming up hard. Okay, so now I want to feel it now. I don't want to just drive it hard with the impact. I want to be able to feel what kind of tension I have on there. I mean, those little, I can't believe how powerful those 1/4-inch impacts are, right? I mean, I was taking some lug nuts off of a trailer, literally, with the stupid thing, and I was quite impressed with the whole performance there. All right, this looks pretty good. I'm gonna give it a, oh yeah, silence. Blessed silence. Okay, So I think we're cool. I'm going to clean this keyway a little bit more, and then we can start putting the rest of the belt sander back together. We still got some welding work to do to fix the platen, or excuse me, the platen and the backing platen. So now that we got the motor back together, this is the next thing that we're going to go after here, and this is the table platen, and you can kind of see it's got some whoop-de-doos in it there that we're going to take out. What I decided to do, this lasted 30 years, so I'm just going to trim this back so it's straight and weld this on and blend it and call it a day. I don't know if I'll be around in 30 years to repair it again, so we'll, all right, so I think we're going to go over to the mill and we're going to knock that off so it's flat, and then cut a piece of this and do a little bit of welding and blending and put it back together. So see you over at the mill. So we got a couple choices here. I can lay it down like this in the vise, and then mill it off with the side of the end mill like that, right? But then I have to hand crank, right? So me being the lazy guy that I am, I really want to put it this way, right? But this is a little bit too much headroom there, a little free waggle. So what do, right? Well, we're just going to support it is what we're going to do. And this is not a super fussy kind of an operation. So I'm just going to back it up with some other plates that get up close to the top. Now I can use the power feed. And honestly, I don't need to even bolt those in. I'm just going to sandwich this whole mess here, like so. Put a little bit of Gronk on this. And then what I'm going to do is slap a couple of cant twists on here. And this bait effectively sandwiches that free to vibrate part, nicely. Like I said, I'm an eternal lazy guy, right? And always looking for the easy way to do things, right? Which isn't always bad, right? All right, let's crank that down. And then now I can use the power feed effectively, right? All right. So whenever you engage the power feed while you're in the cut, always go the opposite way that you were testing it. How do I know that? Drop it down a little. Might be the one. cleaned up. All right, so take this burr off and we're going to knock a little bevel on this so that when we weld this on, there'll be a little bit of weld material left to hold that on there securely, and we can get a nice flush grind here. Don't need much in this case. I want to be able to fill it up in one pass, right? But still have a decent amount of weld on there. And you notice I'm not going 45, I'm going lower than 45. Okay. Now, let's cut a piece of this off. And I want this a little bit longer so that I got something to grind. That, cut to the line. I'll be right back. All right, let's clamp this down so kind of holds everything flush and proper. And I will tap this so that, yeah, I want to make sure there's some hanging over on either side. Cheat it back just a little, okay. I'll get some tacks on that and then we'll weld it up. Cool off for a sec, and then we'll dust it off with the grinder.
Okay. So next is we're going to repair this platen, and you can see it actually where the camera's set up now. If you look here, there's some whoop-de-doos in here that from the belt running over that area. So what we're going to do with this is the other side is good, so I'm just going to take the fasteners out here and re-tap them on this and flip it around, and I'll bead blast this and clean it all up, and then that should just last another 30 years. So, but anyway, I just thought it was cool that you could see that from a distance there. Those little bellies in the belt, I guess, is what caused that. So this belt platen, I bead blasted it. That it had a little bit of rust on it and stuff. But I noticed that so here's the original mounting surface here with the tapped holes. And that's a factory edge, so it's pretty straight and pretty good. Well, when I flipped it over after bead blasting it, I noticed that this is just a saw cut here, so it's not particularly straight. And it didn't need to be, the way it was set up. So we got to do the same thing we did on the other. Let's see, make sure I got it in there right. That we did on the work platen, and then what I did was I measured where those holes were and which side they're offset to, and marked it up here so that I don't bozo that, because it has to be. You know what? I'm second guessing myself. So let's see. We were offset forward before. Offset forward before. Yeah, okay, then that's still. Oh, wait a sec. No, I got to be careful here. I still want the top to be the top, right? When I flip it this way, so my arrow's going the wrong way here. My arrow is going the wrong way, so I'm closer. Yeah, I'm closer to this side. Right? Hold it back in. Like I said, I got to be careful here. Yep, I got that right. Okay, all right. Anyway, let's get it up in there and get to work on it. Ouch. So yeah, we're gonna do the same. Okay, my clamp came off. Low spot there. It doesn't look like it's going to take much to clean it up. Maybe 10 pounds, something like that. Gloppy glop. Ooh, that's a lot. Come on. Well, that's better. I think I need a little chamfer on there. Okay. Rinse and repeat.
Come on. There it goes. Looks like my holes line up. First bozo check, right? Yeah, it's they were offset to one side. You see, there's a little step here, and when you flip it around, you got to be a little bit careful getting your. Oops, is that the right one? Yeah, must be. Getting your offset going in the right direction. So that's what I was fussing with over there. Yeah, it's a little angle on it. Like, I don't want to gronk that one down with the impact at an angle like that. That's just asking for trouble. All right, that's pretty good. Okay, nice flat platen again, and then go ahead and put our fence on here, or excuse me, our work platen. If you haven't seen these are these adjustable knobs, right? So you can adjust the orientation of the lever however you want, and they're pretty handy for stuff like this. So let's see. Let's see, do I have that? Yeah, it's over here. Let's go ahead and slide this in. See what it looks like here. Alright, pretty happy. Put that up to the front. Okay. Yeah, boy, I don't know what I'm going to do. It's brand new, huh? Alright, let's get the motor back on. And we have to make a couple of, these are special nuts that I made that hold the motor up against this faceplate here, since it's not a C-face motor. And it looks like a couple of these got lost over the years, so we're going to spin a couple of these out over on the lathe, and then wire it back up and give it a test, see how quiet it is now. So here's the special nut that we're making, and like I said, I lost a couple of them apparently. They vibrated loose or who knows what, but anyway, they're gone. All I got is this. This is 5/8 hex here, and I got some 3/4. It's a little bit bigger, but it's not going to make any difference for these. It's just a nut. There's plenty of room for it. And so we're not going to worry about it. I know that some folks out there having mismatched nuts would probably send you guys into a tizzy, right? So let's clear that. And then let's see what we got feed-wise here. Slow feed. Let's calibrate the tool. That's enough to get a diameter measurement off of, which I can't see because the camera's in the way and I got a hat on. 6:30. And I'm just gonna go for it. All in one shot here. Can I get on there? Yeah, looks like it. Okay, so under ½ inch is what I wanted. It's like 496. So drill and tap. Let's get this out of the way. Make sure it doesn't hit. And off we go. Looking at the chips coming off of there, I might guess that that's 12L15 leaded steel or something. So it's got a, it's got some chips that look like that. So all right. I'm just putting backwards pressure on it. That way the tap's not trying to drive the 100-pound tailstock back all by itself off of some little threads. Okay, so I think we're gonna put some little chamfers on there. Take the edges off. Am I in the way there? That's okay. A little bit there. A little bit there. And a little bit in the hole. Okay. And then, what are we parting off with here? I'm going to use this here. This is just going to be a scale part off here. It's not a, once again, we're not building a moon lander here in this particular case. Alright, well, all I got one nutski. Well, some of you sharp-eyed viewers might have picked up on this. This is the one I just made, and we showed the process. There's the original. Somebody missed the dimension, huh? So the flange is 1/8 inch, the shoulder is 1/4, so we got 1/8 and 1/8 there. Anyway, that's what happens when you try to remember things and talk on camera. So let's do a proper one. Although this one probably would work, but let's make it to the original spec as close if I can. All right, let's mount the motor here. can see the little the motor studs stick through there, and then these special hot whammy nuts. Let's see what I want to do there. Oh, you know what? I just realized how I probably lost the other ones. You see this? The belt goes by there, and if it tracks off, it hits that nut, and probably just spun it off just for fun. Ideally, you would use a C-face motor on this. Let's see, I need a wrench here. A C-face motor that, you know, mounts on the end face, but I didn't have that, so hence the odd nuts. I'm changing the strain relief here. It's got one of these, I don't know, cheapco strain reliefs. I'm going to put a nicer one on there that has a seal and everything, because I got it. I happen to have it. And not that this box is like, you know, weather tight or anything like that, or watertight or anything like that. That'll be okay. There. So we're going to strip. Something like that. That was the old one. So what I was just doing there is this little lever on the side rotates that knife 90 degrees so that you can slit the insulation long ways too. But I kind of have the depth set a little bit shallow anyhow. I'll leave them alone. Alright, I guess I need strippers. Okay, nice and square. So much better. This thing was so noisy. It was ear-shattering. All right. Well, this thing's back in action. Total cost, 2 bearings and some time. So the bearings were $9 and $7, I think. So under 20 bucks for bearings. and a little bit of my time, and this probably got another 30 years of life left in it. So, great.